Last week we have discussed COs, POs and entire syllabus of 5 units. That gives the brief idea about entire syllabus of PSOC. Now let us discuss about evolution of power systems. Since the inception of the power system, how it is improved step by step till now. In this lecture, we will discuss about these topics. So the commercial use of electricity was started in late 1870s. So it was the starting stage of use of the electricity, and later the first electric power system was established in 1882. So it is commissioned and established in the year of 1882. This first electric power system, it was consisting of simply generators, cable, fuse and load. So here generator, it is a DC generator, and load, it is a simply incandescent bulb. And to transmit the power, we have the cable, and for the over current protection, so it is a simple protection device. That time we were using this fuse. The first electric power system, so it consists of DC generator, one's cable, over one protective device, it is a fuse, over current protective device, and load, so it is a incandescent bulb. This was the first electric power system. It is a low voltage DC system. It was a low voltage DC system, and it was established, it was designed by Thomas Edison. First electric power system was by Thomas Edison at Pearl Street Station in New York. Now, this DC system, earlier it is consisting of 59 customers. The first DC system were consisting of generator, cable, fuse and load. It was a low voltage DC system, and it is designed by Thomas Edison at Pearl Street Station in New York, and it is a simply DC low voltage DC system feeding 59 customers. First 59 customers, and in the radius of 1.5 kilometers. So it is a customers located in the radius of 1.5 kilometers. So it is a system, and voltage level, it is a 110 volts, and we are using the underground cable, and simply it is a incandescent lamp. So it was feeding only bulbs. So that means the first power system was used for lighting purpose only. It was used for lighting purpose, and it was a low voltage DC system, and it is in the year of 1882. And later the motors were developed by Frank Sprague. If the electricity used only for lighting purpose, it is not that much appreciable. If it is used only for the lighting purpose, it is not that much appreciable. It should be used for some way, for something. It should be useful for the mankind. That's why the motors were developed by Frank Sprague. After developing these motors, the electricity was so very much useful that time, because these motors convert the electrical energy to the mechanical energy was possible. So because of this, these motors will be used in many applications. So the use of electricity was more at that time. After inventing these motors, the use of electricity was more, and the usage of electricity increased, and because of this, there were certain problems were occur. These are the limitations of the DC. When the motors were developed, the usage of the electricity was increased. Because of these problems, limitations of the DC become very much visible. It become apparent. in two aspects, that is high losses and voltage drops. If the load is increased, then the current is increased, so losses will be increased. And also if the customers, number of the customers are increased, then the distance of the system will be increased, so voltage drop will be there. At the far end, the voltage will be very much decreased. Limitations of the DC become apparent in the two aspects. So that is the higher losses and voltage drop were there. It is the drawback of the low voltage DC system. Simply we are using the generators only that time. Simple DC generator were there, DC generators. If the number of the customers are increased because of the invention of these motors, there is a increase in the usage of the electricity. Because of that, limitations of the DC become apparent in the two aspects, higher losses and voltage drop. Now people think of that there should be a need of some transformation of the voltage, because if the customers distance is increased from the generators, then the voltage is decreased. If you want to maintain the voltage at the rated value at the far end also, you have to increase the voltage level at the generation side, or we need some transformation of the voltage required. At that condition, William Stanley of Westinghouse, so transformers and AC distribution. So it was developed by William Stanley of Westinghouse. So this Westinghouse is a electric company in USA. It is a one manufacturing company related to the electricity. William Stanley of Westinghouse developed these transformers and AC distribution. After developing these transformers, there was a scope to change the voltage level. You can increase the voltage level and you can decrease the voltage level. That was possible. Transformation of the voltage requirement can be done by using these transformers, and AC distribution system were also developed. It is consisting of the 150 lamps at that time. Now, in the 1889, the first AC transmission system was done. So it is in USA between William Falls and Portland. This is Oregon. It was a single phase AC system operating at 4 kV and over the distance of 21 kilometers. It was the first AC system at that time. It was a distance of 21 kilometers. Now there exists a AC system and a DC system. So Westinghouse has a AC system and DC system. It is done by the Edison. So it is a Edison. So AC and DC was there at that time. In the 1889, it is a first low voltage DC system, and because of the invention of the motor, the usage of the electricity was more. So because of that reason, the limitations of the DC become apparent in the two aspects, higher losses and the voltage drops. People think of that some transformation of the voltage was required. William Stanley of Westinghouse. So Westinghouse, it was developed by George Westinghouse. It was the electric company. William Stanley so developed these transformers and AC distribution. Transformation of the voltage can be done at that time. The first AC transmission system happened in USA between this William Falls and Portland. It was a single phase AC system operating at 4 kV and 21 kilometers. So this 21 kilometers is a much distance at that time, because by using the DC, it was only 1.5 kilometers distance, only 1.5 kilometers distance. But by using this AC transmission system, it was the 21 kilometers. It is a very much long distance at that time compared to the DC, because we have the only 1.5 kilometers distance only by using the DC system. Nikola Tesla developed polyphase systems. So this polyphase systems already developed in 1888, and he had the patents of generators, motors, transformers, and transmission lines. So the polyphase generators, motors, and transformers, and that is nothing but three-phase systems over there. And he had all the patents because as he developed all these, so he has the patents of all this. But Westinghouse is purchased all this. Westinghouse bought all these patents. Now completely now in the entire world, AC system were developed by Westinghouse, and DC system was developed by Edison. Yes, he has developed a DC system, so he don't want to lose this DC system. So that's why he advocated this DC system in the entire world to use it. And Westinghouse has the patents of AC system, so that's why he advocated AC system to become popular. There is a controversy between whether we have to go for the AC system or DC system, because as it was the starting stage, we should have the only one platform, whether AC or DC. So we cannot go for the two systems. So there was no much developments, so that's why we have to lay on whether AC or DC system. So DC advocated, or he wanted to make it popular, that is Edison make it popular, and Westinghouse make it popular, this AC system. There was a fight between the AC and DC. Here in the 1890s, controversy on whether industry should standardize on AC or DC, and Edison advocated the DC and Westinghouse AC. So it was the problem in 1890s. So in the entire world, because the uses of the electricity was increased, and they want to go for the manufacturing industries. So if you want to establish the industries, whether we have to establish the industry based upon AC or DC. So that has to be, first we have to fix AC or DC. After that, you can go for the establishment of the industry. Controversy has started, but because of the voltage transformation, so it is a in the AC, it is a possible to increase or decrease the voltage levels, and because of the simpler and cheaper in terms of generations and motors, the AC becomes more popular, and DC is phased out year by year. That was happened here. AC was more popular and using more and more because of the advantage. So because of the transformation of the voltage, and simpler and cheaper in terms of the generation and the motors. So if you want to go for the higher voltage in the DC, so then it is a complicated, because you have to go for the more DC generators. Those has to be connected in series and parallel combinations. So maintenance problem are there, and also one more thing is that so insulation problems. So earlier we have the low voltage DC systems. So if you want to add more DC generators, then you have to go for the proper insulation. At that time, it was not possible to maintain the insulation. So we cannot go for the higher voltage in the DC system by adding the DC series generators. So we could not go for the higher voltage in DC system. So you can go for higher voltage in the AC because of the transformers, and the cost point of view also, so it is cheaper. In the 1890s, more people were started using of AC and than the DC. So slowly AC becomes on rise, and DC becomes phased out. In the year of 1893, the first three-phase line operating at 2.3 kV and 12 kilometers long in California. So it was chosen at nearer to the Niagara Falls. So away from the Niagara Falls at a distance of 30 kilometers. So nearer to the Niagara Falls. It was operating at 2.3 kV. It is a 12 kilometers only. Single phase system, it was a 21 kilometers, but it is a three-phase line. It was a three-phase line. Earlier, it was the single-phase line. So it was the first three-phase line was operating at 2.3 kV at a distance of 12 kilometers in California and 30 kilometers away from the Niagara Falls. In the 1888, so it was a development of the polyphase systems. Polyphase systems, generators, motors were there, and all the patents were bought by the Westinghouse. In the 1890s, controversy whether industry should standardize at AC or DC, and Edison advocated the DC and Westinghouse AC. So here, because of the advantage of the voltage transformation and simple and cheaper, so AC becomes on rise. And in 1893, the first three-phase line operating at 2.3 kV was established nearer to the Niagara Falls. So this was about in the evolution of power systems. So at that time, there are these several voltages were there. So in the voltage level was maximum 165 kV, and later in the 1923 it was enhanced to 220 kV. In 1935 287 kV, 330 kV, 500 kV, 735 kV in 1966, and 1969 765 kV, 1990s 1100 kV. So gradually the voltage was increased from 1922 to 1990s. So it was the 1100 kV in 1990s. So if we go for the more and more voltage, then the current will be reduced and losses will be reduced. So that's why you have to go for the higher voltage in order to transmit the power over long distances. So it is in 1990s 1100 kV was there. Standard voltage are 115 kV, 132 kV, 161 and 230 kV. So these were comes under the high voltage system, and 345, 500 and 765 kV, these were comes under the extra high voltage line. Below 345 high voltage and above 345 comes under the extra high voltage. And earlier frequency were in the entire world we have 25 Hz, 50 Hz, 60 Hz, 125 and 133 Hz were there. These are the different frequencies available throughout the world in the different parts. But if we have the this much of the frequencies, interconnection problem will occur. So if you want to interconnect the system, so we should operate at single frequency. We should operate at a single frequency if you want to connect the or interconnect the systems. So that's why you have to go for the only one frequency in the entire world. But maintaining the one frequency in the entire world, it is not possible. And some people were think to go for the 60 Hz, and some people were think to go for the 50 Hz. So, it was not possible to maintain the one system throughout the world. So that's why it was extended to two frequencies. It was extended to two frequencies. So those two frequencies were, so one is 50 Hz and another is the 60 Hz. So USA and Canadian countries, USA and Canadian countries, they were using the 60 Hz, and some other countries. So it is ASEAN countries and our India also, ASEAN and European countries. So European countries, we are using the 50 Hz. In the entire world, we are having two frequencies. So one is 60 Hz, Canadian and USA countries, and Asian and European countries, we are using the 50 Hz. So these were the frequencies. So earlier we have the 5 frequencies, and at last we were using the 60 Hz and 50 Hz, and present in India we are using the 50 Hz 230 volts, and US it is a 60 Hz 110 volts. Low voltage, high frequency, high voltage and low frequency. So these were the voltage and standards and frequencies and standard frequencies. So HVDC transmission system, again, earlier we had a low voltage DC system. It was Thomas Edison, it was developed, and it was a low voltage DC system. Already it was developed, but he don't want to lose that DC system. That's why he want high voltage DC system. As it is a low voltage, he could not transmit the power over long distances. That is the major problem. And it has the higher losses and voltage drops were there. If you overcome these two problems, then they thought of that the people might use this DC system. That's why a system of HVDC transmission system was designed by French engineer René Thoury when the AC system were in their infancy, and when the AC system is slowly increasing making the popular, the HVDC system was developed by René Thoury. During 1880 and 1911, 11 Thoury systems were installed in Europe. So the most among the 11 Thoury systems, the most prominent was the motors to the Lions located in the France in 1906. So 1906, so it was developed, and it was the most prominent, and it is spanned at a distance of 180 kilometers and having the 4.5 kilometers underground cable. It is a 180 kilometers distance, but in the 180 kilometers distance, 4.5 kilometers was the underground cable, and it was operating at or transmitting the power of 4.3 megawatt at a voltage of 57.6 kV. 57 point, it is a very high voltage, and current 75 amperes. It was the high voltage DC system period 1880s to 1911. 11 Thoury systems. The 11 Thoury system, the theory of this Thoury systems were that usage of the DC series generators. Usage of the DC series generators in series, so that voltage levels will be were increased. So as these are connected in series, DC series generators increase the voltage level, and all the DC series generators were operating in constant current control mode. All these were operating at a constant current control mode of operation. That means in the DC, the power it is given by voltage multiplied by the current. If you want to maintain the power as a constant, either has to be if one is increased, then other has to be decreased, so that we can maintain the power as a constant. Here in the DC system, constant current control mode of operation was there in the entire DC system. That means this DC current, so this current was fixed. But if you want to maintain the power as a constant, you have to vary this voltage. There is a variable voltage in the DC system, and current is the constant. In the AC, it was a different. In the AC, it was a different. So voltage was fixed, and current will be changes in order to maintain the power as a constant. But because of these DC series generators, more number of the DC series generators were used. DC series generators were costly, so it becomes more cost compared to the AC system. And also the maintenance problems were also there. So it was a very much difficulty in maintaining these DC series generators, and installation problems were there. Because of all these also, so these Thoury systems were not that much of the popular, because they have to go for the more number of the DC series generators, and it was more costly, and maintenance problem were there, and installation problem were there. Even though he has developed this 11 Thoury systems, so slowly it was dismantled, and again the AC system were more prominent at that time. in the 1938, all the Turi systems were dismantled. So all are phased out because of the drawbacks of cost and maintenance problem and all these difficulties. And in the 1920, transfer were developed, but these were not used commercially. So in the 1950s, mercury arc walls were developed. By using this mercury arc wall, there was a possible to convert AC to DC.